I'm going to talk a little bit today about how we've been using StreetLight to fill in some of our traffic data gaps for some of our projects. So I'll talk a little bit about two of our more recent projects. These include the Western Avenue Bridge Replacement Project over Interstate 95 and the Bangor Street Road Diet proposal. And for each project, I'll discuss how we use StreetLight to fill in the gaps in our traffic data in order to create accurate traffic models in order to establish the baseline conditions, analyze alternatives, and analyze maintenance of traffic schemes for construction. So the first project is the Western Avenue Bridge Replacement Project over Interstate 95. So Western Avenue serves as one of the major routes to and from Maine's capital city of Augusta. And this project involves replacement of a 6-lane bridge on Western Avenue, which passes over the interstate at a skew. You can see in the aerial image here that the bridge is closely abutted by an intersection on the left and the interstate ramps on the right. These intersections are constraints to the bridge construction, the construction zone, and limit options for how traffic will be maintained on the bridge itself during construction. So due to these constraints, maintenance of traffic schemes include lane reductions on the bridge and detour routes, and therefore it's important to model the entire corridor and surrounding roads to fully understand the mobility impacts that construction will have on the corridor. The second project is the Bangor Street Road Diet proposal. So Bangor Street is another major route to and from the city of Augusta. And the road is currently a 4-lane, 25-mile-per-hour undivided roadway with 2 lanes in each direction. The road diet proposal would include reducing the number of through lanes to 1 lane in each direction and adding a center 2-way left turn lane. The project has the potential to improve both safety and mobility along the corridor. For both of these projects, Maine DOT uses SYNCHRO models in order to understand the existing traffic conditions, maintenance of traffic alternatives for construction, including lane reductions, temporary signal timings, and detours, alternatives for improving safety and mobility, including long-term changes to the existing network, and future traffic conditions as applicable. So when creating models for corridors, there are often gaps that we find in our traffic data that we need to be able to fill in. And some of these gaps in our counted data include outdated data where recent traffic counts may not have been collected, varying data due to variations in data collection methods, including classification counts, tube counts, or turning movement counts, and missing data. So some side roads or segments may have never been counted. There are also some limitations to collecting data in certain locations. In some locations, data collection can be hazardous, such as on interstates or high-speed roadways or interstate ramps. And it can also be difficult to collect, such as at complex roundabouts or intersections and weaving segments. It can also be timely and expensive to collect, as we have to send people out into the field to either manually collect the data or to place and pick up data collection devices. So StreetLight has been a really useful tool to us in helping us to fill in some of these traffic data gaps for our modeling. So we've used StreetLight to get turning movement counts for uncounted intersections along the corridors in both of these projects. So for the Western Avenue Bridge Replacement Project, we used an origin-destination analysis using pass-through bidirectional gates at each leg of each intersection along the corridor as shown in the map. The origin-destination analysis was used to determine both turning movement percentages and volumes at each of the intersections, and we were able to look at both AM and PM peak hours for the analysis. From the origin-destination analysis, we obtained an origin-destination matrix. So this matrix allows us to isolate the origin and destination zones at each intersection and determine the traffic movements by volume and percentage. And we apply the percentages to our existing counts to estimate the turning movements to and from uncounted side streets, and the volumes to adjust older traffic counts to existing traffic volumes. One area where StreetLight proved to be particularly useful for the Western Avenue Bridge Replacement Project was looking at the interstate ramps. So we were able to use the origin destination analysis to estimate our uncounted ramp volumes, analyze the weaving ramp traffic for the segment shown on the map here, and understand the mobility impacts of the detours and maintenance of traffic schemes. It was particularly important to understand the origins and volumes of the southbound on-ramp traffic, as the maintenance of traffic detour schemes included utilizing a temporary ramp connector from an adjacent roadway, which is shown in the yellow box on the map. So this connector would be used in order to reduce the number of vehicles that have to cross the bridge during construction, which would allow for us to reduce the number of lanes on the bridge itself during construction. On the Bangor Street Road Diet Proposal Project, we used origin destination and zone activity analyses to evaluate traffic on the side roads, including total hourly volumes, directional volume by using entering and exiting gates on each leg of the intersection, and estimating turning movements at each intersection. One of the intersections that StreetLight was really helpful for this project was the Coney Street roundabout at the southern end of the corridor. So this roundabout is a complex multi-lane roundabout with 5 approach legs. So these types of intersections can be difficult to collect accurate traffic data for, as there are many movements and lanes to observe. We did, however, do some in-person counts for the major movements through the intersection to and from Bangor Street. Some of the pros to doing the in-person counts include the ability to capture lane utilization and observe safety issues. But there's also a lot of cons, including not being able to capture all of the movements to and from the intersection legs, general human error in the amount of distractions out in the field, limited collection of data due to short observation times, and difficulties following movements of vehicles through the roundabout due to vehicles making unexpected lane changes. We use StreetLight origin destination analyses to supplement our collected data at this intersection and better understand the traffic movements through the intersection. The results from this analysis were used to understand how the roundabout would operate with a road diet on Bangor Street, the impacts to traffic at the roundabout and on each leg in various scenarios, namely looking at where a lane reduction on Bangor Street could begin, and what modifications, if any, should be made to the roundabout. StreetLight has proven to be a useful tool for Maine DOT in our planning projects, allowing us to understand traffic movements at important intersections and estimate traffic volumes on otherwise uncounted streets.